Good evening. It is February 16th, 2015, and as you know, we have some snow coming again tonight. So hopefully you guys are going to keep yourself safe, and in the event that they do cancel classes, I've gone ahead and prepared this PowerPoint presentation for you guys. I want you to be able to look over this material and read through Chapter 22, but also I wanted to give you a little bit of instruction along the way. So respiratory system, what are we talking about? Breathing, right? Supplying blood with oxygen and making sure that we can get rid of the carbon dioxide. We want to also use the respiratory system for a couple things. I mean, use your imaginations, right? It's for olfaction and speech. What are we talking about? Just that, talking, you know. Olfaction is smell, so therefore our respiratory system, dealing with our mouth and our nose, would be those two major things, right? So the process of respiration is a couple different steps. It's pulmonary ventilation, it's external respiration, transport, and internal respiration. When we're discussing ventilation, that's the breathing part of it. Okay, that's really right there at the respiratory system, and that's moving air in and out of the lungs. Just as simple as that. Just straight movement of air inside and out of the lungs. When we talk about respiration, that's going to be where the gas exchange is happening. Okay, so external respiration is going to happen between oxygen and carbon dioxide, and that's going to happen in the lungs. That's where the lungs and the blood are going to exchange the oxygen, carbon dioxide. The carbon dioxide is going to be pushed out of the body, and the oxygen is then going to be put into the blood, where it can then be transferred or moved around in the body. And that's kind of where that transport piece comes in, and that's just moving it to all the tissues that are involved. Any tissue in the body, any cells in the body that need oxygen are going to get it from the blood. Internal respiration then is just kind of the second step behind that, and that's where the oxygen and carbon dioxide is being exchanged at the actual blood level, which is in the tissues. So that's a systemic system. That's part of the circulatory system. The transport of blood, obviously, we know that to be circulatory, and then of course the exchange process between the blood and the tissues. Okay, that is the internal. So again, just to reiterate, ventilation is your breathing, that's bringing air in and out, and then respiration is going to be the gas exchange. External is happening at the lungs, internal is happening at the tissue levels. Some of the anatomy, of course, we have the major organs, the nose and the mouth. We have the nasal cavities, larynx, trachea, pharynx, bronchi, lungs. These are the major structures involved. There's a great picture that's taken straight from your book that you can take a look at. Functional anatomy or respiratory zone is your site of gas exchange. So where is gas exchange happening? Well, remember, that happens microscopically in the bronchioles, all the way down to the alveoli. And then the conducting zone is going to be where the gas exchange sites are happening. This is all respiratory structures. What are they doing? Well, we saw some of the structures before where they were going to be utilizing cleansing and warming the air as it comes in. The other thing it does is humidifies the air. And those are really important pieces of that because we have to have that air be warmed. We don't want to just go outside right now, especially today, and take a big deep breath of that cold air because everyone knows if you do that it's going to burn. So it warms the air. The other thing it does humidifies the air. We don't like to be too dried out, so we have that humidifying effect that happens there as well. Also, you know, some of the functional anatomy, we're going to look at the muscles involved here. The diaphragm is a really important muscle because it's going to help with the ventilation process of bringing air in and pushing air out. So, individual anatomy pieces, I'm not going to spend too much time on this. I'd like for you to go through and read over nose, what is it doing, then the couple different regions within the nose, the nasal cavity itself, what is responsible with the nasal cavity. We're looking at olfactory mucosa and respiratory mucosa. Let's see, what kind of cells are involved here. This takes you all the way back to Chapter 4 in AP 1, right? Pseudostratified, ciliated, columnar epithelial. What is that telling you? Fake stratified. It looks like it's multiple layers because of the multiple layered areas of where the nucleus lay, but it's really just one single layer of ciliated columnar epithelial. What else is really important about them? Well, the fact that they have those cilia that move the mucus around. What's the mucus coming from? Well, mucus secretes from those goblet cells. All right, so just remember the structures when you're looking into it. Functions of the nasal, we can see during inhalation, we're talking about filtering, moistening the air, and then during exhalation, we're trying to reclaim some of that heat and moisture into the areas. Homeostatic imbalances, we might see something like rhinitis. You can look straight at that and hopefully we can break down that term and see that that itis is an inflammation. The rhin is talking about that's a root word for nose. So we can spread that information. There's an inflammation that goes into the nose and then it affects the mucosal layers and it spreads from the nose into the throat and into the chest and becomes very painful. The pharynx is the next, and there are three regions of the pharynx. There's a nasopharynx, an oropharynx, and a laryngopharynx. You can look at them anatomy-wise and know that the nasopharynx would be behind the nose, oro behind the mouth, and then the laryngopharynx is where it's going to connect up with the larynx. And here is your structural picture. Nasopharynx, of course, is the area around the nose, air pathway from the nasal cavity. Oropharynx is where it meets up, and it's a passageway for food and air. That's one thing that's unique about the oropharynx versus the nasopharynx, is that we're not supposed to have any food in the nasopharynx. Right? Sometimes we have milk come out of our nose or something along those lines, but for the most part, we just have food and air going in the oropharynx and the laryngopharynx, not so much in the nasopharynx. Laryngopharynx, again, also a pathway for food and air, and it's going to extend to the larynx where it becomes continuous with the esophagus. What are its functions? It provides an airway. It's a route for air and food to go into the proper channels, and then also your voice production because your vocal cords are here. We have the larynx, which is the next piece, and that's really just a big chunk of cartilage. And this is what we think about with like that thyroid cartilage, especially prominent in males, that Adam's apple. It is a ring-shaped bunch of little cartilage pieces. I think there's 9 that are going to keep the airways open. And that's really important because we don't want that area to be collapsed. It will provide for much easier breathing as we are bringing in air during that ventilation. The other thing that we have to remember about this point is this epiglottis here, and that's just a little piece of elastic cartilage that covers the laryngeal inlet during swallowing. Also, it's covered in taste buds, which contain mucosal layer. Why is that important? Well, it makes sure that food goes down the right tube, right? How many times have we been eating something, especially like popcorn, and we say, oh, food went down the wrong tube? Well, the epiglottis is not doing its job if that's what happens. So, of course, here's some structure you can look at. You can see right there it starts at the hyoid bone, which hopefully you guys know that hyoid bone is unique in that it doesn't interact with any other bone in the body. Well, that's important because it actually hooks in with a lot of this cartilage that's here. And that laryngeal prominence, that's that Adam's apple that you would notice. Larynx is the vocal ligaments, or has the vocal cords, true vocal cords, and the glottis, the opening between those vocal cords. What happens? How do we produce sounds? Well, we vibrate the folds, which as air passes by it hits those vibrations and it makes the sound come out. And that's how you get to listen to me right now. We also have some vestibular folds, which are your false vocal cords. There's actually no part in sound production, but they help the glottis close during swallowing. And there's a picture of it. Epithelial, you can look at the type of cells you have there. Stratified squamous epithelial. What does that mean? Multiple layers. And the inferior vocal folds will have pseudostratified columnar again. How is voice produced? Well, speech comes as a release of expelled air while opening or closing the glottis. And our pitch is going to be determined on the length or tension. The loudness really depends on the force, right? We can really talk loudly if we push a lot of air out, or we can talk very softly just based on the amount of air that we allow to come out of our mouth. How do we shape that sound? Well, we use our tongue, we use our soft palate, we use our lips, lots of different ways. You can even use the pharynx will help out just by pushing that air out of the mouth and shaping those pieces. The larynx has some vocal folds that can act as a sphincter, so you might need to use something like Valsalva's maneuver, which closes the glottis to prevent exhalation. Abdominal muscles contract and the pressure rises. That helps us to empty our rectum. What does that mean? Well, it's like holding your breath or holding it and trying to push out some fecal matter. That's exactly how we do it. Or during heavy lifting, if we're trying to pick something up, we can hold our breath and really contract those abdominal muscles to help move it. Our trachea is the next piece, and that's our windpipe. That is where we take air down into our lungs. The trachea is going to split. It has a couple different layers, the mucosa, submucosa, and adventitia. There's some muscles that are involved with the trachea, but really take a look at how structurally open this trachea is here compared to the esophagus. Esophagus, much smaller and most oftentimes going to be collapsed if there's nothing coming in. Trachea, C-shaped cartilage, which holds it open all of the time. Electron micrograph of the cilia, or another really good picture from your book that shows the ciliated areas. Really a pretty cool looking picture. I really like this. That's why I included it. So the trachea then are gonna branch down, and they're branching into the bronchial and subdivisions, and they are moving down into what's called the bronchial tree, and that's going to split into a whole bunch of different areas. The trachea have a right and left main, which are your bronchi. Those are your primary bronchi, and then each one will split into lobular or secondary bronchi, and there is going to be 3 on the right, 2 on the left. And how many of you know why there are 3 on the right and 2 on the left? It's because of the lobes that are on the left and the right side of the lungs. Okay, 3 lobes on the right, 2 lobes on the left. The bronchi are then going to change down. They're going to go into segmental or tertiary bronchial, and then bronchioles and terminal bronchioles, which are going to be the smallest. Essentially, they become smaller and smaller until finally they get down into the alveolar range where they can exchange the gases. Conducting zone from bronchial through the bronchioles, the structures occur because the cartilage becomes less and less regular, and they will be smaller and smaller. We have relative amounts of smooth muscles that increases, and the increase in the smooth muscle really is there for the constriction. Right? We need to be able to constrict and push out, so that's why we have that smooth muscle available. Respiratory zone, we have respiratory bronchioles and alveolar ducts, alveolar sacs. There's about 300 million alveoli that make up the lung. That is where you're exchanging the gas. Okay, that is where carbon dioxide and oxygen are exchanging. So 300 million different alveoli, or these little clusters, which are going to be allowing the gas to exchange. Looking at the membrane, it's really thin. You can see it has a gas exchange because of that simple diffusion is allowed because of how thin the membrane is. So just keep in mind we have a single layer of squamous epithelial at most of the alveolar walls. That single layer is allowing for permeation and permeability so the material can move across, especially the gas. All right, so I am going to pick up on next video. We'll go into the alveola.